All right, hello everyone. Today we are going to be looking at the first topic in our AP Calc AB adventure. We're going to be looking at what limits are and their notation, so how to write them algebraically. Before we get going, let's talk a little bit about what these videos are and what I expect you to get out of them. They're going to be fairly short, probably about 15 to 20 minutes. However, it's probably going to take you 30 to 45 minutes to get through one of them because I do expect you to hit the pause button, rewind, listen to things multiple times, because it's going to be very hard to take in and really understand the information at a deep level if you just hit play and 15 minutes later you're done. Plus, you're going to be wanting to fill in your notes, write down any questions you may have so that we can answer them either in class or by another form of correspondence. If you've already talked about limits in a pre-calc class, that's okay. I know you may or you may not have. I'm not sure exactly how far you got with limits, but we are going to start from the foundation because it is a foundational concept in AP Calculus. So we're going to make sure we have a thorough review, whether this is the first time you've looked at what a limit is or whether it's the third or fourth time. So let's jump right in. Let's look at our do now. Number one says, what is the value of the function at x equals 1? So let me pull out my pen here. Guess I got to turn it on first. Okay, so at x equals 1, we are coming up here, and we actually realized, oops. Okay, this pen may or may not work as well as I want it to. So we come up here and we notice that the function actually has a hole at x equals 1. So the value of the function at x equals 1 does not exist. There is no y value. So we can just put DND for does not exist. Now, if we look at number 2, we'll see that the question is slightly different. It says, what value does it look like the function should take on at x equals 1? So no longer are we looking for what the value of the function actually is at x equals 1, but rather, what does it seem like it should be? So essentially, if we are tracing the function, right, up to x equals 1 from the left-hand side, and we also trace it from the right-hand side, it certainly seems like the function should hit y equals 1 as we get to x equals 1. Again, the function doesn't exist at x equals 1, but it looks like it should be equal to y equals 1. I'm just showing you that that point is at y equals 1. So we would say y equals 1. And this is the idea of what a limit is. It's not a specific value of the function, but it's rather what does it look like the function should be? What does the function approach at a certain x value? So again, you can see as we come in from the left, the function's approaching the function's approaching y equals 1, and it's the same as we come in from the right. The function is also approaching y equals 1. So this is the idea of what a limit is. Now, before we move on, I'm actually going to give you another couple visual examples of what limits are. I'm going to erase this work, and we're going to hop down to a blank sheet of paper. And again, if you need to copy down the notes before I erase them, just hit the pause button and you can hit play when you're ready to go again. So I'm going to draw one big graph. Let's put a function up here. I'm going to put have a few different things going on. Okay. Let's call this -3, call this 1, we'll call this 4, let's call this 2, 5, -1, and up here we'll have 6. I'll put a little point up there just to let you know that that point does exist. Okay, so there are several different ways that a graph can look, and this is not, of course, all of them, but this is 3 common ones that you may see as we move forward in this unit. If I want to look at the limit as x approaches -3, so I want to look at the limit as x approaches -3. Well, I'm going to trace the graph from the left-hand side. I'm going to trace the graph from the right-hand side. And I'm going to see that they both approach the same y value from the left and the right. They both approach y equals 6. So the limit, and we'll call this graph, let's just call this graph f of x. I'm going to show you some notation here, which we'll get into a little later. But the limit as x approaches, the limit as x, what is going on? I'm too far off the screen. Okay. As x approaches -3 of f of x, in this case is equal to +6. And again, the key thing here is that the function is approaching +6 from both the left and the right-hand side. Or, as we'll learn later, we can say from both the positive and the negative side. Now let's look at another example here. Let's use blue. So the limit as x approaches 1 of f of x. Now we're going to trace it from the left-hand side, or the negative side, and we're going to trace it from the right-hand side, or what we call the positive side. And we'll notice that they both seem to be approaching -1. Now, the problem is the function's not defined at x equals 1. There is no value there. But again, for a limit, it doesn't matter. We are only looking for what value the function is approaching, not what value the function actually has or attains at that x value. So in this case, our answer is this limit is equal to -1. Again, it does not matter that the function's not defined at x equals 1. It merely matters what the function is approaching, and that the function approaches the same value from both sides. Now we have one more. We'll use a light green for this. So the limit as x approaches 4 of f of x. And again, we'll talk about this notation in a second. I'm just exposing you to it now. So let's trace the function from the left-hand side, or what we call the negative side. And right here, it looks like it's approaching -1 from the left-hand side. Now, if we approach from the right-hand side, it's not approaching the same value. It's approaching what looks to be y equals 5. And then we have a third thing going on here, the actual value of the function. So f of 4 is actually equal to 2. Okay, now this doesn't matter. Does not matter. Because as I've mentioned before, for a limit, we are not concerned about what the value of the function actually is. That is irrelevant. What we are concerned about is what is the function approaching. So the function's approaching -1 from the left-hand side. The function's approaching +5 from the right-hand side. Because those values are not the same, this limit does not exist. Okay, so hopefully, and again, you can go back and rewatch this, pause this. Those are just 3 examples of what could happen in or at certain spots in a function regarding limits. A key takeaway here is the function must approach the same value from both sides for the limit to exist. If it doesn't, we get what happened over here in green, and the limit will not exist. All right, we're going to go back up to the first page and pick up where we left off in our notes. All right, so we already answered the first question. The second part right here says the limit is not a specific value of a function, but rather what the function, hopefully we can all fill in this blank by now, approaches my penmanship will get better the more videos that I make as it gets closer to a certain x value. Today we're going to focus solely on understanding limit notation and how to write the description of a limit analytically. The limit above can be written in the following way. So again, up here we were looking at what is the limit of the function as x approaches positive 1. So we're going to start off with the abbreviation for limit, LIM. Now whatever the function is approaching is going to go right below it. So we're talking about as x approaches 1. Then you need to list what the function is. In this case, this function was f of x. Actually, let me just double check that real quick to make sure that's correct. Yes, it was f of x. And then you're going to put whatever it equals. So in this case, let me just get my pen again. In this case, this equaled, because the function was approaching the same value from both sides, this limit was equal to 1. Okay, you can read this in two ways. You can read it the limit of f of x as x approaches 1 is equal to 1. Or you could also say the limit as x approaches 1 of f of x is equal to 1. There's not one specific way you need to say it. You just need to make sure you include all the necessary information. You need to talk about what the function's approaching, the name of the function, and what the limit actually is or whether it doesn't exist. So let's move on down. Okay, we have an example here. It says, given the function f of x equals x plus 1, write the correct notation of the limit of f of x as x goes to 2 or x approaches 2. So let's approach x equals 2 from the left. Let's approach it from the right. Good news is they're approaching the same value, so we know that the limit does exist here. And now we're just going to write our notation. So the limit as x approaches 2 of f of x is equal to, and it clearly looks like it's approaching the y equals 3. So that would be an acceptable answer. Now, this is not the best way to write this. This would be correct, but there's a more specific way. Everything's going to stay the same. So I'm going to say the limit as x approaches 2. But now instead of just saying f of x, it tells us what f of x is, right? It tells us that this function is x plus 1. So if they give you the equation for the function, it's usually best to write that. Okay, because it's just more specific to the reader, then the reader doesn't have to go searching for what f of x actually is. You just give it to them in your limit equation. All right, let's move on to the next page. If you look at this graph over here, you'll see that it looks like the third part of our example that we did all the way at the bottom. There's a discontinuity, specifically a jump discontinuity in this graph. So if we wanted to look at what is the limit of f of x as x approaches 3, right? We're going to approach x equals 3 from the left. We're going to approach it from the right. And they're not going to approach the same value. So hopefully you've picked up that this limit does not exist. However, we can look at what we call the one-sided limit. So we can look at the limit of the function as we approach from the negative side or the left-hand side. And we could look at the limit of the function as we approach from the right-hand side or the positive side. And these would be one-sided limits. So we look at each individually. These are limits where we're only looking at what the value of the function approaches from either the positive or the negative side. Now, if you're confused about what does positive or negative side mean, just think of a number line. Right? put 0 here, we'll put 3 and -3. Now, if you pick any point on this number line, let's just say I pick a random point here. Okay, as you move this way, the numbers are going to be positive, right? As you move this way, the numbers are eventually going to get negative, right? So if we say we're approaching from the negative side, well, that's going to be the left-hand side. And if we're approaching from the positive side, that's going to be the right-hand side. Okay, just because eventually, if you keep moving along the number line to the left, you're going to get to negative numbers. Even if you don't immediately start at negative numbers, like let's say this is 2, obviously as you start to move this way, you're still at the positives, but eventually you're going to get to the negative numbers, right, if you keep moving. Same thing can be said with the right-hand side. You're eventually going to get to positive numbers, regardless of where you start in the number line. So up here, we really have two answers. We have y equals 2 and or y equals 3. Now again, if we were looking for the regular limit, we would have to say it does not exist because the function is not approaching the same values from both sides. Okay. The limit of f of x, I skipped down here, as x approaches 3 from the negative side. So again, this time we're looking at the left-hand side. That's going to be equal to 2. Now, if we want to specifically describe the negative one-sided limit or the left one-sided limit, most things stay the same. We say the limit as x approaches 3, but we can't just leave this as 3 because that would represent a regular limit. We only want to represent the one-sided limit. So we have to put a little negative up by the 3. Okay, that means we're solely looking at the limit as we come in from the negative side or the left-hand side. F of x is our function, and that is equal to 2. Okay, notice how I left the function as f of x. That's just because I don't know what this function actually is. Okay, all I know is that it's called f of x. If I knew the specific function, then I could put that, but f of x will suffice for now. Now, if we look at the other one-sided limit, the limit as we approach from the right-hand side or the positive side, well, let me get my pen out again, not my eraser. Okay, we are approaching 3. So we would say the limit as x approaches 3, but remember we are approaching from the positive side, so we're going to put a little plus up here of f of x is equal to 3. So again, the only difference here is when you're doing a one-sided limit, you need to put the little plus or minus sign next to whatever value the function is approaching. Okay, if you forget to do that, then the expression or equation means something completely different. Because notice if I just left it as, if I just said the limit as x approaches, I think when I go too far off the side of the screen, it does that. As x approaches 3, now this is just talking about the entire limit, the regular limit. Take 5 seconds to think about what the answer to this one would be. Maybe pause the video. Okay, the answer to this one would actually be does not exist because the function's approaching different values from the left and the right-hand side. Right, so these 3 limits are all valid ways of describing what's going on with a function as it approaches 3. And really, you would want to understand all of these 3 because if you just give 1, it doesn't tell the whole story, right? If you just say the limit doesn't exist, well, okay, we know that the function's not approaching the same value, but we don't know what those values are. To give those values, you could talk about the one-sided limits. All right, let's move on. I think we have 1 or 2 more examples. Oh, just 1 more. All right. Okay, so this time we are given g of x. Let's label that right away. It says write the correct notation for the limit of g of x as x approaches -1 from the positive side. And then we're going to evaluate the limit. So it's approaching -1 from the positive side. So in our heads, hopefully that should mean the right side. Use a different color. So we're approaching -1, and we see that it's going to hit y equals -1, or that's what it's approaching. So our limit as x approaches -1. Now remember, we have to put our little plus sign up here to show that we're talking about the one-sided limit from the positive side of g of x is equal to -1. And then number 2 just asks us for the other one-sided limit. So if we approach from the negative side or the left-hand side, we see that we are approaching +2. So the limit as x approaches -1, but from the positive side of g of x is equal to +2. All right, so let's hit the pause button for a second. I realized I made a mistake when I rewatched this video before posting it, and because this limit right here is approaching from the negative side, we should have a little negative sign up here, not a positive sign, because we're approaching from the left, not the right. So as this video continues, it is going to revert back to what I had originally, what was in red, but just notice, please note that that was incorrect, and we should have what I currently have up here in blue. This would be the correct notation for this limit. All right, sorry about that, and hope you enjoy the rest of the video. Okay, so hopefully this video gave you a fairly good introduction of what a limit is and the notation for how to write limits. Now you do have some more practice in the rest of your packet, just writing regular limits and one-sided limits, and also trying to understand the difference between the two. So you should take a look at that. Again, write down any questions you have about the video if I didn't answer them in my explanations, and then we can get to them at a future time. All right, this is Mr. Fawcett from AP Calculus AB. Have a good day.